Hello? Can everyone hear me? Okay, we got Ruben. Hello, Ruben. Josh. Hello, Josh. I'm just seeing how many people join in today. If not many, we'll probably not do it tonight. Let's see if it's worth it. Lights, camera, action, sure. Yeah, Ruben, thank you. How was your guys' day today? Hopefully good. Anyone watching it, just say hello or put a comment there so I know exactly how many people watching, so I may not continue. Are you guys watching on phone or the laptop? Hello, Gary. How are you? It's a bit late for you, Gary, isn't it? Let me grab some equipments, guys. Gary, bad words, not allowed. YouTube will ban you. Phone, yeah. Maybe if you got a bigger screen, Joshua, it might be better. Maybe. So my quality, audio, everything good? We all aren't as rich as you. Are we really doing this, or you guys want to go to bed? It's up to you. Can you hear me? Should be good. I can hear you. Sorry, I can hear you on my microphone myself. No smart comment tonight, Gary. Of course, I'm always organized. I'm the man. All right, give me a few more minutes, guys. I'll just play an intro and I'll set a few more things and we get into it. Hey. Okay, everyone. Audio is good, video is good, I believe. Sorry, I took a little bit of time there, but that's what happens when you're doing everything live. Ruben, you need to come and help me, brother. Switch my cameras and equipment around. Okay, hello everyone. Hello Joshua. Hello Ruben. Hello Gary. Whoever else is left in the chat watching us live. Okay. Everything is good. I'll actually do it. I'll love you to come and do it, brother. It's difficult to set everything up, but it's fun. It's all good. Okay, today what we have here is Ford Focus. Okay, guys, we got a Ford Focus in the house today. 2012 model. It's got an issue with fuel. Actually, it has multiple issues, but today we probably focus on just one problem, which is the fuel gauge on the dash. It's empty. It's not showing fuel. Okay, that's where we at. Okay, before we start, any question, concern regarding the car and everything? And we can move on and start doing some diagnosis here. Okay, we still got Ruben, Josh, anyone else in the chat? How many viewers we got currently? I don't think there's too many today. Well, it is getting late, but any question regarding the car? You want to know something before I jump into the car with the diagnosis? Anything you want to know regarding the car? Regarding the problem so far I've discussed. Okay. So we got only few people watching. Fair enough. Anyway, let me get into it. It's a 2012 Ford Focus fuel gauge issue. I'll quickly show you what the customers are complaining about, right? Okay. All right, basically just there on the fuel gauge you can see, right? There's not much happening there. So fuel gauge showing empty right there. Right, the ignition is on. Let me turn the ignition on and off. Ignition off, ignition on. Not much happening there. Alright, try again. Ignition off and on. That's off. That's on. It sort of bounced a little bit. Very, very tiny bounce there. I can see on the needle. But I don't think the camera is picking that up. Very, very small bounce, but it's still below zero. And the fuel lights stays on. Even after you start the car. Alright, that's the issue with the car. I'll start the car quickly and you can see nothing changes. The fuel light stays there and the fuel gauge is still empty. Alright, that's the problem we are trying to diagnose today. Okay, where should we go next? What's the next thing we want to tackle here? All right, any comment before I move on? What should we do next? Okay, what we got here? Ruben says, ha ha ha, ha ha ha, brother. Gary says, use scan tool to control. Okay, anything else? Joshua, do you have any comment? How should we approach this? It should be very easy for you, Josh. What should we do next? Let's go. I got still all that from yesterday, so let me clean that quickly. Use a scan tool to control. I'm still waiting for Joshua's comment, what Joshua has to say here. Gary says use scan tool to control. Definitely. Why do you assume that we have to check with the scan tool already? Gary, why do you think we should do that first? So everyone knows where you're coming from and all that. Can you get the fuel pump? I'll get to the fuel pump housing. Okay, Joshua says, can I get to the fuel pump housing? I had a quick look. No, you can't. You've got to take the tank out for this one. So there's no fuel door, fuel pump housing access door on this vehicle. So that's where we're at. Hello from Sri Lanka, Prasan Shan. Welcome, brother. Welcome. To test the fuel gauge to check system. Gary says to check the test the fuel gauge to check the system. And Joshua says, or the wiring, okay, or the fuel pump. So in this vehicle, we can't get to the, excuse me, you can't get to the fuel pump door, access door. Usually behind the seat or in the boot. That's where we at, right? So Gary suggests let's do the scan tool test, system check, and then Josh also said let's do the wiring. Can you get to the wiring to the fuel pump or whatnot? So just to let you know, this is a diesel vehicle as well. 2012 Ford Focus diesel. It's a 2-liter, I believe. Duratorque, it says on the cover, engine cover there. So it may not have a fuel pump in the tank, right? But we'll figure it out soon. Okay, let's go. So in my opinion, we should really quickly go and do some scan tool. Okay, it's pretty easy to do. Let's do that first, like Gary has suggested. So let's see if there's any fault code, because this is a new technology, right? New vehicle, so they usually have some kind of electrical system that connects all the fuel gauge and all that system too, I believe. So let's do the scan tool check and let's see where that takes us to. All right, so let me just scan everything again. Try from the beginning. Let's go there. Vehicle VIN detected, right? So let's go scan that quickly. Let's go there. And we got the car information, right? And we got automatic selection, manual selection. All right, let's scan the fault code. I'll just scan everything on the system here. Prasanna has a comment. Is it Euro 6 emission system? I don't know, brother. I don't know and I don't care at this stage. We're not dealing with emission system here. It's just a fuel gauge system, so I'm not too worried about it so far anyway. So we got two fault codes on the BCM-I and IPC. So BCM-I is your BCM body control module, and IPC will be just your instrumental panel control, I believe. So let's see what fault codes come up with, right? All right, I'm just going to quickly see what the fault codes are. So right here we got the fault code on the IPC, instrumental panel, fuel level signal, okay, that's the fault code. Invalid data received from BCM, okay. Now also on the BCM we got a fuel level sensor I circuit and steering wheel module. I don't know, steering wheel module may or may not be related to this problem, but definitely we have some fuel level sensor circuit fault, right? Okay, now before anything, what we can quickly do is we can use a scan tool here, and then we can probably do some activation test if you guys want me to do, or let's just clear the fault. Let's see if it comes back real quick. Because it does says fuel level sensor I circuit fault, right? So what that usually means, in my opinion, is the BCM is going to get the signal for the fuel level from the tank. So the signal will go to the BCM first, and then BCM will send that information to instrumental panel for the dashboard. So via a CAN bus system, that's what I can think of without looking at any information, right? Because on the instrumental panel, you see the fault code, it says fuel level signal. And it's also said the invalid data received from body control module. So body control module is not sending that data to instrumental panel control. That's control module. That's what it sounds like, right? So I don't think that the gauge, the fuel level gauge sender unit in the tank is connected to instrumental panel directly. I think it goes to BCM first. Now on the BCM you can see, right, fuel level sensor I circuit. Don't worry about that steering wheel module fault at this stage. Fuel level circuit sensor I circuit. So it has some kind of circuit fault here. So it could be your sender unit itself. It's got an open, close. We don't know if it's an open circuit or closed circuit, right? But it says sensor I circuit. You could have problem with the earth or the wiring. Anything is possible at this stage. So looking at the fault code description, that's what the design looks like, because the instrumental panel is not giving us a circuit fault code. It's only giving us that it's not receiving signal from the BCM. So the system gonna be laid out on this car is sender unit to the BCM and BCM to the instrumental panel, okay? That's what it sounds like so far. All right, so far everyone's following. Gary has a comment. Gary says probably 5. I don't know what that means, Gary. Also, Gary has a comment, record, clear, and retest. And I also don't know what that means, Gary. You need to elaborate a little bit for me. Everyone else following so far? Let's see how many people are on the comment here on the video. Not many people today, but if you guys are bored, let me know. I'll just shut everything down and go home. Okay, so far, any comments, concern? What should we do next? What I just described regarding the layout of the system, is that something you can, you understood, or do you think I could be wrong and you can correct me? I'm happy to hear your thoughts on that. All right, while we wait for some comments, I'll quickly write it on the board what I'm talking about regarding the system layout here, right? So the sender, let's call it a sender, but on the scan tool we saw it says fuel level sensor or something like that. Okay, so they call it a fuel level sensor. So this gonna go to my BCM. This is my understanding, BCM, and then BCM is gonna send it to instrumental panel, IPC. Okay, this is my understanding. So this is done between communication via communication CAN bus system, and this could have wiring going directly to the BCM. Okay, this is the system layout in my understanding. Need to see full wiring diagram. Yes, we need to see full wiring diagram, but let's see how much we can do here without looking at the wiring diagram. If you follow me, you know I don't like to use wiring diagram that much unless I am very, very desperate for a wiring diagram. I need to have the wiring diagram. But let's see how far we get to, okay? All right, Euro 5. Gary has commented Euro 5. That must be for Prasann. I don't know if I'm saying your name right, Prasann. Forgive me if I'm pronouncing it wrong. Prasann, Gary. Okay, Josh. Joshua, Ruben, any comment, any thoughts? Where should we go from here now? I hope all my videos and sounds coming clear. If there's an issue, just let me know and I'll try to fix it. All right, I'm still waiting for a few more comments to come in and I will continue on. All right, Ruben has a comment. Ruben says, can we do a test through the scan tool on fuel gauge? Definitely. I'm pretty sure we can do it. Looking at the scan tool faults and the design that we think it is, right? We definitely should be able to do some testing with the guides on active tests, like bypass testing on the scan tool. Just so I am confident here, can everyone see my board and writing everything, all the letters and everything? Or is it too far from the camera? Just let me know and I'll fix it if you can't see that. All right, guys? Okay. Clear faults. Okay, we can clear faults too, Josh, if you want. Let's clear the fault, and you want to see the fault code come back, I believe. That's what you're doing. Okay, let's do a couple of things here. Clear the fault codes. Let's do what Ruben has asked. Let's do the activation test on the gauges. Let's see if we can get somewhere from. All right, let me go and clear that fault code real quick for you guys. bring that camera forward a little bit. Okay, let's do the clearing of the fault. So I'll just go and just quickly clear everything. All right, let's go and erase fault code. I'll maybe cycle the key on and off. Sometime the fault code might not come back on until you cycle the key once or twice, right? Let me just cycle that key once or twice. And let me just quickly go and scan. I don't really want to go a full scan, so I'll just go to control unit and let's see what's on the BCM, right? So let's try that. Trouble codes, ignition is on. Scan tool is just communicating. I can hear the horn and clicking under the dash. Yes, the fuel level sensor circuit fault has returned. The other two fault codes, there's a fuel level circuit fault again, and then there's a right door ajar switch. I don't really care about that. The first one is a history. The first one, we got the history and the current fault. Okay, they're the same fault anyway, same fault code numbers and all that. So I can go back to the IPC, which is my instrumental panel, and I can also scan the fault code there. Trouble codes, we got some message there. Okay, let's continue. I can hear the beeping going on the dashboard, right, which is normal when the scan tool is trying to communicate. They do that on most Ford vehicle I've seen anyway. Alright, so fuel level signal, the same fault code has returned. So this is for the Joshua's comment, fuel. So now let's move on to what Ruben has asked us to do, which is do activation test. So I'm going to go just simply on the activation test here. I'll just put this aside for a minute. Okay. And I'll bring the camera with me so I can show you exactly what's happening on that dashboard. Alright, hopefully everyone can see that. I'll just zoom that right in a bit. So that's my fuel gauge right there. Alright, I'm gonna go onto my active test. Let's see if there is one. Sometime you don't have, sometime you do, so let's just figure it out here. Right there we got fuel gauge indicator control right here. Okay. Live data, do I need any live data? Not really, just pick one, I don't care. Not important. Okay. Now it's sitting at 1% fuel gauge indicator. Let me increase that. 26%, 76%, 100%, and you can see the fuel gauge is working. It's getting down, 75, 50%, 25%, and that's 0%. So active test working. The instrumental panel, the gauge needle is going up and down, so we know that part is more than likely good. Okay, so far we've done everything what everyone has asked. Okay, so I got a comment from John. John, hello, welcome brother. BCM live data related to, John has a comment, BCM live data related to fuel sender unit. Yep, we can try that next. We also have a comment from Prasanna again. What is the code set criteria from it where we can get an idea? I don't know, brother. I don't have information. So I don't have a factory information. So this is not a Ford dealer. So I'm just using the resources and tools I have. So I hope I could tell you that, but that's where we're at. All right, we got few more people joining in. Welcome everyone. Welcome everyone. Okay, I will quickly show you on the board so far what we've done, so we can all understand where we're at. So if you cannot see my board, everything, right? Just let me know, and I'll try to fix the camera angle and whatnot. Looks like there's a little bit of glare happening with the lights, but just let me know how the quality on the board is. So far, we've tested. There's a fault code on the BCM and IPC, right? And we know they communicate via CAN bus, COM line, right? Now, the IPC is my instrumental panel, obviously. So the IPC, we did some active bypass testing, and we can move that gauge up and down, no problem whatsoever. So what that means, in my understanding, is there might be nothing wrong with the IPC, because we can control all that thing in the IPC, and IPC is giving us fault code saying there's no signal, I'm not receiving any signal. So I don't believe there's anything wrong with the IPC, and I also do not believe there's anything wrong with the communication line, okay? Because if there was a communication fault, the IPC will have more than just the fuel gauge fault code, or more than just the fault code regarding, fuel system or whatever not. There will be other system not working as well, because it's going to get a lot more other information from other computers via CAN bus system. So we only got the fuel system fault, meaning I would say this communication line is good, the IPC is good. Now we can focus on this area now. So this is out of the picture. We don't have to worry about just yet. We may have to come back to it, but for now, that's what it looks like. Okay. So next, where should we go? Okay. Gary has sent a message saying now test quality of fuel in the tank. I don't know what's it's got to do anything. Can you make sense for me, Gary? Why should we test the so quality or quantity? So if you're asking quantity, okay, this is what I've done so far on this vehicle. So customers told me that the fuel gas doesn't work, and they've already put the fuel in the tank. And they said it's full tank. They couldn't put any more fuel in the tank, but the gauge is still showing 0. So we know there is plenty of fuel in that tank. It should be full tank, according to the customer. So when I received the car, I mean, like, okay, sometimes customer could lie. They don't know what they're doing sometimes. Not everyone knows about cars. So I thought, okay, I'll try to put some fuel myself. And I couldn't feel it anymore. It's up to the neck. I can't go anymore. So full fuel tank is full, okay? Gary Webb also send me, can't see board, use different color. Can everyone see my board, or do I have to change? Gary has said he cannot see the board, so please let me know if everyone following. I may have to move my camera or whatnot here if not. Okay, so Joshua has sent a comment. Do you have a wiring pin out for the BCM? Not just yet. I haven't looked into it just yet, Joshua. I don't know. I don't have nothing at the moment. Prasanna says, I guess he meant quantity. I think so, Prasanna. I think Gary meant quantity, and I'll just explain. It is full tank, and I know that for sure. Okay, if everyone can see my board, not when I'm standing in front of the computer, when I'm actually writing on the board, can everyone see my board and read everything? If so, give me a yes, so I don't have to move the camera around. I'm trying to capture me and the board at the same time, so I don't have to move the camera around. Gary says correct, that's what he meant, fuel quantity, yes. Can everyone see my board? I need to know, please, otherwise I need to repeat it again. Gary says no. John says yes. So what it is? What is it? Is it a yes? Is it a no? Can someone else confirm that for me, please? Sorry, lost the sound. Okay, so basically everyone is saying that they can see my board. I don't know why, Gary, your screen maybe not showing a quality. Maybe your internet is down. Maybe just try that. Everyone's saying the quality is good on the board where I'm writing. They can see it. So anyway, what I was saying is next step, I think we should try to go and do some testing at the sender unit, which is obviously in the tank. I don't want to take the tank out with the full tank of fuel. So I'm going to go and, find the excess behind somewhere, maybe under the seat, see if I can get to the wiring, whatnot. We'll see. We'll figure it out. So give me a couple of minutes. Let me go and see if I can find excess where we can do some testing. Gary says, Gary has a comment, still use scan tool for fuel level. Still use scan tool for fuel level. Okay, can you elaborate on that, Gary, so I know exactly what you want me to do? So while I'm doing the back seat, I'll let you guys watch the board and so sort of take it in what I'm talking about on the board. No sound. Still no sound? I think I can hear it. All right, Gary, I don't know what scan tool you want me to use, what fuel level on the scan tool, but I'm going to go to the back seat now, and I'll show you guys what I see there. Okay, Joshua has says, let's check the wiring and feed a resistor up the sender unit. Yep, we can do that, Josh. Ruben has says, test sender for 55 earth. 55 earth. I don't know what 55 earth means, Ruben. Prasanna says, I could be loose wiring at the pump. It could be loose wiring at the pump. Yeah, we know, but I can't get to the pump. So let's go back there and let's see. This is what I've done at the back. I pulled the carpet out. The seat, fold the seat up, carpet out. There is no access to the tank. I can get to the wiring, looks like it's going to the tank. Okay, I ripped the tape up a little bit and we're going to do some testing there. Okay, can someone tell me what we're going to expect there? Okay, that's where we're at. So judging by the wiring, there's 4 wirings there. I'll quickly explain to you on the board before I go there. There's 4 wires we can see on that wiring harness. Okay, so the 4 wire. So looking at the wiring on that going to there, can you tell me what we're going to expect on that wires? Okay, there's 4 wires on that wiring harness. I can't get to the plug, it's underneath. You just go through a grommet. Maybe I can get to the plug through the grommet, but it's a very, very small grommet. I can't get to the fuel pump. So there's 4 wire, okay? So wherever the wiring is coming in, we got 4 wires, guys. Okay. Can you tell me what we're going to expect here? In my understanding, right, 2 thin ones. Yeah, Josh has commented 2 thin ones. So what Josh has meant is on the wiring plug, on the fuel pump a lot of the time, if you see, let's say 4 or 5 wire, usually 4 or 5 wire, that's how they work. The thick wires, the 2 thick wires usually going to be for your fuel pump. Okay, and then 2 thin wires or the 3 thin wires usually going to be for your fuel sender unit or the fuel level sensor. That's how it's going to work. So what we're going to find there is I can see there's 2 thick wires. I don't know if the camera is picking up or not. There's 2 thicker wire and the 2 thinner wires, okay? So let's say these 2 wires going to have a positive battery voltage for the pump. The other thick wire going to have a negative battery voltage. All right, this is thick wire, this is also thick wire. And the 2 thinner wire, right, going to be for my my fuel gauge control. Now, without looking at the wiring diagram, we can do this test right there easily. I don't need a wiring diagram. I can show you the wiring diagram after this. Let's see if we can figure it out. But I don't need the wiring diagram to do the simple testing like this. Most of the time, not saying every time, most of the time they're the same. Universally, doesn't matter if it's BMW or Great Wall of China or Jeep of America, we don't care. They all work the same when it comes to simple circuits like this. All right, we got Josh says 2 thin wire. Yep, that's right. 2 thin wire is going to be for my gauge control. Yep. 2 fat wire could be pump. Yeah, definitely that's always the case. So always the 2 thick wire is going to be a high amperage current because the pump's going to need more amperage than the sender unit. So always they put 2 thick wires, okay? Most of the time, not going to say 100% of the time, 99% of the cars I've seen, 2 thick wires, pump, other thin wires for your sender unit. For the gauge, okay? And now Ruben also says power, earth, bias and reference. Power, earth, bias and reference. Power, earth, bias and reference. That's 4 wire, Ruben. What do you mean? Power, earth, bias, reference. So you mean power and earth for the pump and a bias and a reference for the fuel gauge? Is that what you mean? Possibly. But we only got 2 wires left. Like I said, there's only 4 wire. So 2 out of the question. Fuel pump. We know the car runs. We don't need to worry about it. I don't even think this
actually sender unit has pump in it. Because the Ford used the same harness for petrol and diesel cars, so the wiring harness is same. So when they put the same wiring harness on the diesel vehicle, even if there's no pump, the existing wire is still going to be there unused. But whatever, we don't need to worry about these two thick wires for the pump. We're only going to worry about this two thin wire. So this is the pump, right? So now we got two wires left, Ruben. So how does it going to work? Okay, and I'll tell you how it's going to work. Usually they will have 3 wires or 2 wires sender unit. The 3 wires, usually on the European cars, mostly I've seen, 3 wires going to have, like you said, exactly like the position sensor or the pressure sensor. That's how they're going to work if it's a 3-wire sensor. So on a 3-wire sensor, you're going to have 5 volt coming in most of the time, right? You're going to have a bias possibly, maybe 5 volt or maybe 0 volt, no bias. And you're going to have an earth. Okay, that's the 3-wire design on the fuel gauge. But if it's a 2-wire design, you're not going to have all this. On a 2-wire design most of the time, and if it's a computer control system like that, like we said, it goes to the BCM first. So it's going to be some kind of computer design, right? Not a basic old school design. So I would say on this 2-wire, we're going to see maybe 5 volt or 12 volt on one wire. It could be 5 or it could be 12. Okay, on one wire, let's say that's a positive. Let me just get that thick wire, never mind. On one of the thin wire, and the other wire is going to have what? Earth. Because it's going to need earth to change the voltage range, isn't it, for the computer, right? So just think as, let's say, just think as a coolant temperature sensor, how it works. It's going to work pretty similar, okay? I don't know the engineering behind it. What's the computer going to look like inside? I don't know that, but I can tell you they're going to work exactly like the coolant temperature sensor. So if I made a circuit here of a coolant temperature sensor, right? So we got a ECU. In this case, we have a BCM, right? BCM is making that fuel gauge work. So BCM is going to have 2 wires coming out, right? So one wire is going to be my 5 volt or the 12 volt power supply, right? And the other wire is going to be my earth, negative. And then we're going to have a fuel sender, which is going to be a register, which varies with the float going up or down, right? That's why we got a line variable register. So on the inside the computer, we're going to have an earth supply. And then the power supply will come through some kind of source, obviously regulator, voltage regulator, whatever. Power supply is going to come, and then computer is going to do its measurement right here between these 2 wires. But before that, they're also going to be a resistor inside the computer. So basically, the measurement of the voltage, the computer that's doing is going to do between 2 resistors. Okay, if you connect that between this resistor and this resistor, can you see what I'm trying to show you here? It's going to do the measurement between 2 resistors. So it's exactly how the coolant temperature sensor works. On a coolant temperature sensor, resistance is going to go up or down on the sensor, right, according to the coolant temperature. And computer is going to know how many voltage it's at. And that's how its computer is going to know the temperature, right? Same thing. The fuel level is going to move that resistor up or down. That's how it's going to drop or increase the voltage on the on the voltmeter. Let's say, for example, it's a voltmeter inside the computer. Exactly like that. There's no difference. So now, knowing all that, do we need a wiring diagram? I don't think so. We can do it absolutely without a wiring diagram here. Okay, Ruben has said yes to the last comment, I believe. Prasanna has a comment saying, short 2 thin wires with a test light to see if fuel gauge needle moves up to rule out wiring. Okay, that's not a full statement, Prasanna, but I know what you're saying. That's not a full statement. We're going to short power and earth with a test light. We don't actually need a test light. We can short it directly in this case because it's like a coolant temperature sensor. You don't need to protect that circuit. It's already protected. Even if you breach the wire, the 2 thin wires, these 2 wires, directly without any test light, you're not going to harm anything because they got a register inside the computer before that power comes out. So this register is going to take all that voltage that you're sending by bridging the wire. So yes, we can do that. Test light might also work the same. We can also drop the voltage down, but it's not necessary. Okay, bridge them. Joshua says bridge them or register wheel. Okay, bridge them or register wheel. In this case, register wheel can also work. Just directly bridging onto the earth can also work the same. Okay, so you mean what Joshua has meant here is find that 5-volt wire and put a resistor between the two wires, or what we can do is we can directly connect that 5-volt to earth, and it's going to do the same. It's going to drop it to 0 volt, right? And we can see if the needle on the gauge in the dashboard goes up or down. Okay, that's basically everyone saying the same thing. I think everyone knows what I'm talking about. Everyone's following, which is good. But before that, now we know what we expect on the wire. Let's go and find out if you got that on the wire or not. Okay? Okay, I'm going to go there. Let me do some testing now. Okay, I hope everyone can see this. I don't want to block the view, so let me just fix that camera quickly. Okay, let me just sort of put it there. Okay, all right, hope everyone is seeing this. Okay, so we got blue with the black wire. We got a yellow with the blue wire. So these two wires are thick wire. Okay, these two wires are thick wire. I don't need to worry about it because we already said it's for the fuel pump. But just for curiosity, let's just check it out anyway, what we see here. All right, I got my probe connected already. Okay. So obviously, I don't want to cut this wire. Wire kind of comes through here, goes in below the carpet and inside the grommet there in the middle. So I can't disconnect the connector here. So let's just try the thick wire. Let's see what we got on the thick wire quickly, right? So I'm just going to use my piercing probe. I know, don't poke a hole, but I don't care. When you're desperate, you got to do desperate things. Okay, I'm on a yellow wire. Let's see what we got here. I'm going to just use my tester. I got 12 volt on that wire. Okay, let's see if that 12 volt is a true 12 volt. Okay, so I'm going to connect my test light to the battery negative. I'll find something on the door here, negative, and I'm going to find I'm going to find a power here. And my test light lights up. You can see, right? My test light lights up. What that means, it's a 12 volt supply for the pump. Okay, we don't care if there's a pump or not at this stage. Let's test the other thick blue wire. Let's see what we got here. Okay, I'm going to connect my probe again. Let's see. Quickly have a gauge of what you're getting. So I'm getting earth on that wire. Okay, let me connect my test light to power. Just using my probe here. All right, I got positive on the other side. I'm going to look for earth. So when I find the earth, this test light is going to light up, right, like that. So we connected to the blue wire, the thick blue wire. Let's see what we got. We got earth. Permanent earth and permanent power on the thick wire, which is for the fuel pump, okay? But we don't need to worry about that. That's not what we're here for. So if the fuel pump wasn't working, maybe the car wouldn't be running, right? But car runs, so we know that circuit is good. Let's focus on the two thin wire. We got the green with the kind of like a blue, yeah, green blue and a yellow kind of like a purple, yellow, violet color. So just to make it easy, it's a green and a yellow, the thin green and a yellow wire, okay? All right, let me see what we got here. Let me just, before do that, check if everyone's seeing everything I'm doing, just in case I need to move the camera around. Okay, everyone can see that wiring, what I'm doing there, or do I need to move the camera around? Can you give me some comments so everyone is looking at what I'm looking at here? Can everybody see my wiring? Yes, Prasanna. Prasanna says yes. Prasanna can see it. I think some of our viewers has left the chat. That's fine. I'm only starting my YouTube, so I don't expect a big audience. One day maybe, guys, if you help me and give me a thumbs up so the YouTube can distribute my videos everywhere. So maybe one day I'll have a big group, but it is what it is. Okay, we see. Josh say we see. Okay, good. All right, let's move on to the other thin wires and let's see what we find there. All right, next one. We got blue wire here, right? Sorry, not blue wire, the thin wires, the green. We're not worried about the thick wire again. The thin blue and the thin yellow, okay? So I'm gonna just quickly test what we got on the yellow wire maybe, or the green wire, doesn't matter which. Let's try the green wire anyway. All right, it's a very thin wire. Just be careful when it's a thin wire using this type of piercing probe. Sometimes it's not big enough. You can buy the thin probes, but I don't have it, so we're just gonna do it anyway. All right, let's see what we got here. Let me get my probe. Okay. We got some resistance there. It's nothing. We got nothing on that screen, you can see. We got no power, no earth on that wire. It just looks like it's open. There's nothing there. Now let's try the other one, which is my yellow, the thin yellow wire with the violet purple stripe on it. All right, let me try that. Nope. All right, there we go. I'm going to connect my probe. I got nothing. I don't think I have any good connection. Let me try again. Okay, here we go. We still got nothing here. Sorry, I got something there. I had something. I lost it again. I got nothing there, guys. Okay, let me try that green wire again. I got some ohm. Let me just put a test light. Let's see if there's any earth coming in or not. All right, my test light connected to battery positive on my probe here. I'm going to look for earth again, and when I find the earth, the test light is going to light up, right? Yes. So on that green wire, I have earth. As you can see on my green wire, I have earth. Okay, so that's my earth for the fuel gauge. Let's try that yellow one again, which I didn't see anything. Let me make a good connection there. And my yellow wire, I see nothing on my yellow wire, absolutely nothing. Let me go back to multimeter on my probe. I got 2.7 volt. I got 2.7 volt on my meter here. Okay? I'm just gonna put a multimeter real quick, because I don't really trust that probe that much. I don't have much experience with it. Okay, just use my normal multimeter here. All right, I'm going to connect that on that yellow wire. All right, this is what we got on the multimeter. You guys can see that, 2.9 volts. Let's say 3 volts there. Okay, so we got earth on one wire and we got earth on the other wire. Okay, let's just confirm that. We did see the earth on the other wire. Let's confirm that again. So I'm just gonna put some power on my test light so I can look for earth. All right, when I find the earth, this test light will light up like that, right? All right, let's go again. On that green wire, I got earth, you can see. So we got earth and a 3 volt on the other wire. All right, that's where we at. We got earth and a 3 volt. Okay, we got some comment. Ruben says yes. Prasan says, I wish you have a big followers soon. I hope so too, brother. Thank you. John says green and blue is earth. The violet yellow is the signal wire according to the wiring diagram. I don't know. I don't have a wiring diagram. So I'm purely doing without a wiring diagram. So green and a blue is earth. Yes, the green is the earth for the sensor. Blue is the earth for the fuel pump. The yellow and violet is the signal. That's what it looks like. Yes, no problem. Thank you for that, John. But like I said, we don't need to look wiring diagram for a simple circuit like this, really. Okay, that's because it's open Bridget. That's because it's open Bridget. What's open, Josh? What is open? That's because it's open. What's open? So we got, on the meter, we got 3 volt, right, on this wire, and we got earth on this wire. Where do we go next? Joshua says the sender. Okay, so everyone, what do you think it looks like now? Where should we go next? What does it look like the problem is? We got 3 volts on the signal wire and we got earth. John says let's go to live data. Yeah, we can do that on BCM. Let's see what we see, right? Joshua says, yes, bridge the wire. John says, BCM should have some information on signal from fuel sender unit. All right, let's do that. Let's go live data quickly, right? Let's see what's on the live data on BCM. Let's go. All right, on the scan tool, I'm going to go to BCM now, like John has requested. Let's go back to my BCM, wherever that is. There you go, BCM. Let's go to trouble codes. What trouble codes we have here? Let's just quickly verify that again. Okay, we still got the same fault code. Let's go to live data. Okay, here we go. Here's the live data. We're gonna look for what? Maybe let's type in the fuel something. There's nothing coming up on the fuel. Let's just go maybe tank. Tank, nothing on the tank. Let's go down. Voltage, brake lamp. Read door, battery voltage, that's it. Windscreen, voltage, tailgate, read door, central lock, lock, unlock. Well, I don't see any fuel sender data here at all. Nope, I don't see it. Excuse me. I don't see any data here regarding fuel, guys. Nothing. But there is a fault code in the BCM. That's kind of strange. It could be there's just a scan tool issue. Just doesn't give us data. Okay, John's comment on BCM should have some information on signal from the fuel sender. There is nothing I can see, John. Prasanna says yes, Bridget. Yes, Bridget. Okay. What should we do next? Let's hear from John. Lol, bridge now. Okay, bridge now. Let's bridge it. Okay. Let's bridge it. Let's see what happens. Okay. So I'm going to directly bridge the wire, the 2 thin wires. Okay. So just on the board quickly. So we're going to go, this is what everyone has asked. Okay. We're going to bridge this wire to this wire directly. Earth. We're going to put earth from the other thin wire to the signal wire. We know the other thin wire has earth, so I don't think we need to tap into that. We can simply just give earth on the signal wire. Okay, that's what we're going to do. Okay, let's just try that. So we said that this is our power. The green one is our power supply wire, right? All right, we got power there. And then the yellow one is our signal wire, which we had 2 volts in it. Let me just tap into it real quick. Without damaging too much of this wiring. It's hard to do sometimes. It is what it is. Okay, I am tapped into my 2 wire. Let me just quickly get that measurement again for everyone on that signal wire. Okay, so on the signal wire we got 2.8, 2.7, if you guys can see my meter, 2.9, let's say. It's slowly climbing up. It's climbing up to 3.1. Okay, anyway, maybe because I'm moving the car, shaking the car with my body, so the fuel gauge is moving. Maybe that's why it's changing that value, right? Let me just try that actually, because it's bouncing up and down. If I don't touch the car, you can see the voltage kind of likes to settle down. Let me just wait until it settles. .6, it's dropping. 2.5, 2. And it goes up slowly again. Okay, it's doing something here. Let me just shake that car real quick. Is that what's happening here? Why is voltage going up and down here for some reason? Let me find a better earth. All right, I'll put directly onto my probe earth. So 3.1. Three volts. And it's slowly coming down. Can someone tell me why it's happening? It's going up and down like that. So it drops down 2.7. I'm on the yellow wire, which is our signal for the fuel gauge. It's dropping down to 2.5, 2.4, and then start climbing up again. 2.5, 2.6. So it drops down and then goes up. Why is that happening? Can anyone tell me why is that happening? Can someone tell me why is that voltage on the signal wire going down and up like that? Okay, anyway, I'm just going to go and bridge it real quick. Bridge the wire and let's see what we can see there. Okay, I got a jumper lead here, right? I'm just going to bridge that directly from there, signal wire yellow to my green wire earth. Okay, just using a direct jumper. I'm not using any resistor. It shouldn't matter anyway for this testing. Okay, let me go and see what's happening on the dash. Okay, All right, right there. You guys just have to trust me so I don't have to move this camera around too much. If you guys can see that, I hope you can see that. Okay, that's my fuel gauge and it's still staying at 0, the same level as before. Okay, I'm going to turn the key off and on. Sometimes you need to do that for the fuel gauge to register the new signal. Key on, off a couple of times, nothing happening. I'm going to start the car. If that changes anything, nothing, it's still sitting below empty. Turn the car off, back on, still sitting below empty. Okay, you just have to trust me so I don't have to show you with the camera. Still sitting at below 0. Okay, what's next? All right, let me focus back in there on the wiring. All right, boom. What we got? Boom. Okay, boom, boom. Okay, I don't know what boom means. I'm not sure. I can fix it. Send 12 volt down the signal wire. Okay, send 12 volt down the signal wire. Josh has commented. John says, I'm not sure. What's the next step? Probably. Joshua says, LOL. Do you want me to put 12 volt down that signal wire? Not sure if I can. Looking at the design, I may not be able to send. I could probably send 12 volt via a test light. That's definitely possible. Do you want me to do that? Let's do that. Let's send 12 volt down that wire. Like Joshua says, I don't know what we're going to achieve, but let's see. We never know. Okay, let me go and do that for you. 12 volt. I'm not going to put direct 12 volt. I will put 12 volt via my test light. Okay, my test light is connected to battery voltage, battery power. When I find the earth, this test light will light up. You can see there is power coming on the tip here. So I'm gonna undo the bridge here, and I'm gonna send that to my yellow wire, which is my signal, we think. All right, that's 12 volt straight into that signal wire. Let me go and see what's happening in the dashboard. Let me turn the key on and off a couple of times. Sometimes it takes time to register. Let's start the car up just in case. Okay, turn the car back off. Ignition on. Nothing is changing here. Nothing is changing. I can show you. Sorry, where are we at here? All right. Basically 12 volt on the tip of this test light. I'll just make sure that 12 volt is getting into that wire. I got 11.71 volt on the meter with the test light connected. So the computer is seeing 12 volt at this stage. Nothing's a joke, Josh. Nothing is a joke. We tried it. Nothing happens. Computer is seeing 12 volt right now. So what's next step going to be? Prasanna says clear the fault code. We already done that, Prasanna, a few times already. Fault code just comes straight back on. But we haven't tried it after bridging it. Maybe you could be right there. Maybe the computer is still seeing the fault, so it's not registering the new signal. Very possible. Okay, Prasanna say, I see smoke. Where do you see smoke, Prasanna? Don't scare me like that, brother. Really? Where did you see smoke? Okay, let's do what Prasanna has says. Clear the fault codes. Yeah, let's put the signal, bridge the signal, or put 12 volt into the signal wire and the earth into the signal wire, and then clear the fault code. And let's see if that makes any changes. All right, so let's do that. All right, we still got the 12 volt supply there, right? Through my test light, 12 volts still going in there. Let me go and clear that fault code. So we probably want to clear that fault code in the BCM and IPC as well, right? So maybe let's go auto scan so we don't have to scan. All right, let's go fault scan everything so we can just wipe everything down at the same time without having to go on back and forth. All right, we can pause that there and I'll just clear the BCM and the IPC. You can see there's faults. Quick erase. Yeah, fault code is erased. I'm looking at the gauge, nothing's happening. Key off, key on. Gauge is still the same. Let's continue the scan again. See if that fault code comes back straight away or not. All right, scanning, that fault code, boom, already come back on the IPC and also on the BCM. So nothing has changed. Let's bridge it. Let's go the other way now. And let's see if we can clear the fault and make this to work. Okay, let's go. I'm going to just bridge the wire. Okay, just using a bridge cable. Bridge, sorry, the... Sometimes I run out of words here. Jumper cable, sorry. Okay, now I still have earth. I still have the power coming on the other side of the test light. Let me just verify that earth is getting into my signal wire. So I'm just verifying that. So I do not have earth coming in here. So I may not have a good contact here. All right, let me just fix that. Now we have earth, right? So the earth is making from the earth wire to my signal wire. So we know it is bridged pretty good this time. Okay, let me go and see if my dash is changing anything on the dashboard. Nothing. Let's clear the fault code again. Okay, fault code's clear. My dash, the fuel gauge hasn't changed on the dashboard. Ignition on and off a couple of times. Let's start the car. You know, nothing's happening. Let's turn the key off again. Key back on. Nothing is happening. Let's scan the fault code again. No. Pause that. Let me just scan my BCM. That should give us indication whether we fixed it or not. Trouble codes. Ignition is on. And boom, the fault code has returned. The fault code has returned, guys. Clearing the fault code has not changed anything. All right, any other ideas here? Where should we go next? Prasanna says he sees smoke. I think I wanna need one now. I don't know where to go next. If you guys can tell me where to go next, otherwise I'll figure something out here. Prasanna says Bridging may cause BCM to see reading out of limit. Use register wheel. If you want to, I can do that too. No problem at all. Joshua says cut the wire. That's what I was thinking, Josh. Let me cut that wire and let's see where that 2 or 3 volt we were seeing there is coming from. Is it coming from the BCM? Is it coming from the fuel sender unit? It shouldn't, because we have earth on the other line, so it shouldn't really have a voltage there, but again, we can definitely do that. Cut the wire, yes. Ruben says, I agree with Josh. Okay, good. As long as you understand what you're saying, Ruben, as long as everyone understands what they're saying, no problem at all. All right, Prasanna do have a comment saying bridging may cause BCM to see reading out of limit. Use register wheel. Okay, if you want, I can use the register wheel. Let's do that anyway. It's getting light. If you guys wanna, go to bed, that's fine. I'll probably continue here. I got my awesome register wheel that nobody can buy anymore. Josh can't buy this anymore. I'll sell it for $1,000 if you want. Okay, let's put some bridge there with the register. Right, I'm just gonna go randomly. I don't know what register I'm looking for here. I'm just gonna go randomly on the wheel. Okay, where we at? We have 2.2 K ohm here. Okay, let's just verify that everything is getting here. Sometimes I have a loose connection on this piercing probe. I still have the earth. Let me just turn that wheel around so I know I'm getting a good connection on the other side of the bridge, just to verify that. I'm not getting anything here. Definitely has a good connection. Maybe my test light is too heavy to measure that. So let me just use the multimeter. That's hard to do with one hand, but I think I'm not making a good contact. All right, I got the register wheel there.
And let me go and see on the dash what we're seeing. Still nothing has changed, still sitting below empty, right? Let me take some voltage measurement here real quick. I'm turning the register around. I'm not making any changes here, guys. Absolutely no changes on the multimeter. You can see, if you can read that meter, I'm making no difference on that voltage reading. It's just bouncing from 2.5 to 3 point something like earlier we saw. I'm not making any difference here. And my dash gauge is still same. All right, what should we do, guys? Next, what should we do here? Okay, Ruben comments here. What we got? John says, can you connect the voltmeter to see the voltage changes as you change the resistance? I didn't see any drastic voltage change there. It's just bouncing up and down like earlier from 2.5 and 3.2 voltage, just going up and down for no reason there. Prasanna, if possible, disconnect the wire, then check. Yeah, that probably will be the next step. All right, let's cut the wire. That's what I want to do. That's what everyone wants to do. Let's cut this wire and let's see what voltage we're actually seeing here. Okay, before I cut the wire, anything else? All right, I'm going to go cut that wire. Okay, I'll get rid of that register wheel here. It's not making any difference for us. Okay, let's just connect my multimeter anyway, so we can see as we're cutting the wire. My multimeter is still connected. Let me connect that to the earth. Yeah, it is connected, so 3.1. Can everyone see the meter or not? Yeah, it looks like you can see that meter, right? 2.9 volt. Okay, let's cut that wire. So the yellow wire is our signal wire, right? So this side is coming from the
BCM, we believe, or one of the computer, and this side is going down to my fuel pump module there, if there is a fuel pump anyway. So let's be cut after where I'm measuring, right? So cut that wire. So wire is chopped, guys. I'm still seeing 2.7 volt on the meter, 2.8, 2.9, 3, 3.1, 3.1, and then start climbing down again. Let's watch how far it goes. 3.1, 3, 2.9, 2.8, 2.7, 2.6, and 2.5, 2.4, and start going back up. It's weird. 2.5. All right, that's where we at. So the wire is cut, guys. Wire is cut. Prasanna, check the wiring upstream. Yeah, upstream where? Where should we go now? Do we even know? Does it go to the BCM? We don't know. Does it go to BCM? We don't know. I don't have a wiring diagram. Let's figure it out. I'll wait for a few more comments, and then we probably go get the wiring diagram. Joshua says wiring diagram time, man. Yep, sounds like it. But before we do that, I want to quickly see if that earth is traveling through my coil, not coil, sorry, resistor in the fuel sender unit. It's coming back out where we cut that wire. Let me just figure that side out quickly. Okay, I'm just going to trim that wire real quick here. I'll trim that side too, just for testing here. Okay, so this is coming from inside the fuel tank, right? So let me just put a... So we got earth on this side, the green wire. The green wire is sending the earth to my sender unit and coming back out on the yellow wire. That's what we believe is the circuit layout here anyway. So I don't know what resistance we have at this stage on the sender unit. We might not be able to light up our test light, but let's see if it can travel. So I got nothing there. I got nothing here. So I don't have any resistance coming through back out. I would say you should be able to measure that resistance, isn't it? But we're not seeing any measurement here. Why is that? So I'm connected to my test, my multimeter on a ohm. Hang on, let me just try that. Still showing me open here on the resistance. Why is that? Don't we supposed to see some kind of resistance here, or do I need to cut this earth wire too? All right, let me just do that. Let me cut that earth wire. I was expecting some ohm there, but obviously nothing there. All right, I'm connected to multimeter, right? I'm just doing some ohm resistance measurement here. And I got no resistance traveling through my sender unit here. That's not normal, is it? Or am I overthinking here? I should see some kind of resistance here, right? All right, my connection is good. It is connected to my multimeter. Let's just double check my multimeter is, my leads are good. I'm just going to touch them 2 wire together. You can see it is functioning. Or maybe not, okay? Maybe not. Maybe my lead has problem here, guys. What am I doing wrong here? Oh, there you go. Sorry, I had to make a good connection on my alligator clip there. So it is working. It is working, but I don't see any resistance traveling through my sender unit. All right. It's gonna be a fun night. All right, that's my resistance in automatic settings. I got nothing there. OL, open. All right, what's going on here? My sender unit is bad. Looks like the measurements, our measurement shows there's open in the my sender unit, right? All right, Prasanna says should be a wiring issue. Joshua says, are we wrong with the wiring? I don't know. I think John has the wiring diagram. John was commenting earlier, he looked at the wiring diagram. So maybe ask John, if John's still watching, are we doing something wrong on the wrong wire? Are you tapping into wrong wiring here? Joshua says, I'm spinning out. I am also spinning out. It's late and it's tired. I thought it's going to be quick and easy. Guess not. There could be 2 problems, Prasanna says, very possible. Not usually the case, very possible though. I'm just going to wait for John. I think John has the wiring diagram. If John could help us with the wiring, are we looking at the right wiring here? Let's just wait for John, see if he's still on the chat. If not, I'll see if I can find a wiring diagram. Okay, while we do that, let me just go and see if I can find a wiring diagram here. It's bad. Josh says it's bad. It's really bad, Josh. All right, let me see if I can find a wiring diagram. My scope here, let me just try Autodata. I think I'm already logged in somewhere else. Let me go and reset that. Autodata only lets you use one computer at a time. Well, at least that's my subscription plan anyway. All right, let's see if we can find a wiring diagram for this.
Ford Focus. I did have a quick look earlier. I was trying to do it earlier, but I didn't see any wiring diagram, I believe. I'm pretty sure I didn't see anything. Which one of these Focus is it? 11 to 15. Let's go to wiring diagram. It's a 2 liter, 2011 to 15, diesel. We got ABS, AC, and the engine management wiring diagram. That's what we have. All right. Let's see what we can find here. All right. Let's type in fuel, maybe fuel sender. So we got fuel temperature rail, separate, no fuel level here. I don't think there is anything. Fuel gauge, nothing. Let's go fuel tank, maybe. Something comes up. Tank, nothing. There is no wiring for me to show you guys. We got ECU there. I don't see anything here. I do not see a wiring diagram at all on my Autodata. Does anyone else has a wiring diagram? Okay, Joshua says it's bad. It's looking bad. It's not making sense so far, but everything we've done so far is pretty valid test, you know. We're still learning something, but we'll get there, we'll fix it. All right, I don't have a wiring diagram. Can anyone, is John still on the chat? Maybe he can help us out with the wiring diagram. Let me just try one more thing here. Okay, so if you go to, I usually have it saved here. If you go to cardiag.com, this is a great website whenever you're looking for a wiring diagram. I've found a lot of the time, if I can't find wiring diagram on my Autodata, I usually go here. It's a free website, cardiagn.com. Just select your brand. Let's see if we can find something here. Ford. We got Focus. Ford Focus. Where's that at? Focus. Where are you? Focus. Here you go. Ford Focus, right? And it'll show you everything that's available on this website. Okay, so let's scroll down. We got 18, 2018, 15, 18, 2010. 2012 to 14, maybe here. Let's see what we find. Okay, this one they want us to download this file and then you can look at it, but let's see if we can find any other ones here. 2008 to 11, I mean this is a 2012, maybe close enough. Let's see what we find here. Wiring diagram, engine, manual transmission. So see, you got all the information here, factory information here, everything. This is a great website. You guys can take a note on this. Electrical distribution, not worry about that. Multifunction electronic module, maybe that's my BCM, right? Multifunction, maybe let's have a look. This is full of ads and stuff, so usually you have to do this stuff. You just gotta find all the buses you can see on the picture and you verify yourself. It says find a bus again. Anyway, that's all right as long as we're getting free information, right? Here you go, multifunction control module, full factory diagram here. Let's see if we can find a fuel system. Is it even the right module? We don't know. Control module function. GEM is installed on the passenger side underneath the dashboard. That's good to know, right? On the, looks like behind the globe box there. GEM, is that the right diagram? Is that the right module we're looking at? I don't know. Electronic module, okay, let's go back up and let's see. Anything to do with the fuel system here? I don't see any fuel system. Removal and installation. Generic. Okay, I don't see any fuel system here, guys, but it gives you the full complete wiring diagram. Let me just quickly have a look at my fault code and type in there. Alright, my fault code is P0460. P0460 is my fault code, guys. P0460. Let me see if I can find that. P0460. Okay. P0460. It's a B code. All of them are B code here. B codes. Where are we? Where are we? It's all B code. There's no P codes here. Okay. Let's just keep scrolling. P. There you go. P something codes are there. P04. I think it's a P04. That's what we're looking at. 460. I don't see a P fault code here. We may not be in the right module here. Anyway, let's go back and let's see what else we find here. Wiring diagram, 2011 electrical circuit diagram. Let me see if we are still good here. Steve said, lol, Steve. I don't know what that means, Josh. Wiring diagram. I'm trying to find a wiring diagram, Josh. I don't have a wiring diagram on Autodata. It sucks, but it is what it is. But this is a great website, guys. If you guys want to obviously look for wiring diagram, I find a lot of good information here. Sometimes it may not be arranged in order. You can just get to what you want to see on a click of a button. Because it's a factory manual, everything, they just put it in there. Let me see if I can find a tank or the fuel or something. Maybe a fuel tank. Fuel tank maybe. Let's do a search here. Fuel tank. I may need to zoom that in a bit more. Fuel tank versus sender. Fuel tank. I can see something here, right? Down here it says fuel tank unit NA, but it's got the fuel pump diagram, but doesn't have a my fuel float sender unit wiring here for some reason. So they call it tank unit. So let's just type in tank instead of fuel tank. Let's go tank unit right there. I see something. Oh, I lost it. Tank unit. You got the fuel pump, looks like nothing, no wires there. Maybe one wire coming down here, going to the ground, but I don't see another wire. Tank unit. That looks like there's, hang on, let me go up. You can see that, right? It says tank unit. We got the sender and the 2-wire, and the pump doesn't have any wiring. So maybe that's the correct wiring diagram. All right, let's try our lock here. Okay, so let me just come down a bit. Okay, we may be at lock here today. Okay, let me go that way real quick. And
All right, here we go. Tank unit. We got 2 wire coming out. There's another one here as well, maybe for 2 different cars. Okay, 2 different models maybe. Hopefully that's what it means. So we got a CB model and an EA model. I don't know what that means. Maybe different version of Focus. So we got 2 wires going in. Doesn't matter which sender unit, and goes to my whatever that is. Let me figure that out. Goes to my, what is this unit here? Hey, it says body control module at the top right here. You can see body control module. So that's definitely is my body control module. It goes directly to the body control module. And let's read what else it has to offer here. So this one says fuel pump level ground, fuel pump level sensor. Okay, must be the signal and the ground for the sensor. Let's follow and let's see what color of wiring they say it is. Okay, so my ground is green blue, which we're on the correct wire, and then my signal is yellow and a violet, VT, yellow VT. So definitely we're on the right wiring, and both goes to the BCM according to this wiring diagram, and I hope this is the right wiring diagram. So that's where we're at, and on the BCM it says plug C2 pin 29 and C2 pin 53. C2 right here I'm reading, C2 plug 53 pin, C2 plug 29 pin. That's where we're at. Alright guys, if you're following me, what should we do next? Here's the wiring diagram. I'm pretty sure the color of the wiring looks right. It goes to the BCM. It says it's for the fuel pump level. So where do we go next? Alright, that's where we at, guys. Is there another sender? I don't think so. Looking at the fuel tank design, I quickly had a look underneath. There is only looks like one tank. It's not a split tank design, looks like. John says to sleep. I think that's a good idea for tonight. John says keep going tomorrow. I don't know about that. I might want to finish this job tonight. I do need to tell the customer what's wrong. But let's see how I go here. If no one's watching, maybe I might just close for the tomorrow. John said sender unit looks open circuit. Yes, I can see that, John. It is definitely looking like an open circuit. What I want to do quickly, maybe right now, obviously we don't know which direction to go. Before we go into the BCM direction, I probably want to quickly put some resistor on those 2 wires. Now it's both cut and open. I don't know that should make any difference. We did that and we see the sender unit is open. That shouldn't have made any difference whether it's connected or disconnected. Now we verified that the wiring is correct, right? If my source is correct, I don't know if my source is wrong. John, probably you do have a wiring diagram. You can verify that for us. I want to quickly put a resistor around those 2 wires that we cut quickly. Voltage from BCM look too low at 3 volt. That's right. I would probably expect about 5 volts or sometimes 12 volt too, but in this case maybe a 5 volt, but it's not looking like that. And the voltage is going up and down. It's pretty strange. I don't know why. Excuse me. So I'll quickly bridge the wires again with the resistor, see if we can make any difference, but let's see anyway. All right, let's go back there. Okay. All right, I'm still open circuit on my sender side. Let's go and try my my wiring coming from the BCM. All right, cut that wire. I will just get rid of that jumper, not the jumper, the piercing tool. So we'll just go directly into the wiring now. I don't know if anyone's watching at this stage, so I'm gonna just quickly go through this. So I'm just gonna put my resistor wheel and then wires. I don't know if my resistor wheel is actually true or not too, so let me just quickly verify that my resistor wheel is working. So I'm still on the resistance, so alright, I'm just going to select one random resistance here. I'm at 10 kilo ohm, 10-15 kilo ohm, and I'm seeing 10-15 kilo ohm on the meter there, so I know my resistor wheel works. So I'm just going to pump that resistance into that 2 wirings we exposed, we cut, going to the BCM, okay, going towards the BCM. Let's see if anything changes on the dashboard. All right, turn the key off and on. I'm still seeing no change. Let's go to my fault code, maybe erase that fault code real quick. Okay, fault code comes back straight away. Nothing has changed here so far. Turn the key on and off. Let me just change that resistance a little bit again. I really don't think that's going to make any difference, to be honest. So I'll just go a little bit higher resistance, 60A, or let me go a little bit lower, maybe 820, 150, 220 ohm. Let's see if that makes any difference. All right, nothing. Let me clear the fault code now. Erase the fault code. Yes, yes. Boom, no fault code, guys. No fault code. Okay, let me just bring that screen up. So basically I put 100 and double check that again, but 150 ohm I think, and my fault code is gone. I cleared it. Let me see if my dashboard, the gauge is showing anything for us.
Okay, let's go. No fault code, guys. And boom, look at my fuel gauge. Turn off, turn it back on, boom. There you go. No more fault code. My gauge is working. Let's go to my IPC wiring diagram here. Sorry, IPC data here. Obviously, it's gonna show us the. Let's go see volt trouble codes. We can clear that now. I don't think it will come back. Boom. We still got the fault. Let's erase it. There you have it, no more fault code. Let's go live data and let's see what my fuel sender unit is showing me here, level. Okay, let's go fuel. Here we go. We got 55 ohm, guys. You can see 54%, not ohm, sorry, 54%. Okay, there we have it. So now I'm just quickly scroll to this register wheel. So I'm showing 220 ohm. Let me go down or up. Okay, on the scan tool, I may need to get the scan tool in so I can see it too. All right, here you go. We got a scan tool. I'm watching the scan tool like you guys. Okay, so we got 53. We got 220 ohm. We got 330 ohm. That is dropping very, very slowly. Obviously, fuel gauge is taking its time to drop the voltage, the percentage down. The IPC is taking its time, but I can change that voltage. No problem here. So what did we do wrong earlier, guys? We were doing the same thing. Did we put too much resistance? That's why we were not being able to do what we had to do. Maybe we put too much ohm here, more than it needed. So what's going on here? This is very strange. I'm still registering some fuel here at 1 million ohm. Okay, let's go to 220,000 ohm. My gauge dropped. Yep. You can see on the percentage my things drop. Let's go back up. Let's go back up to where we had the data. Then we'll go back to 220 ohm again. It's coming back up. So it must not like that range of resistance we were choosing before to feed back into this wire. Okay, there we have it. We got some comment. That kills flat rate, lol. This kills flat rate. Yeah, we don't have flat rate in Australia, mate. We are safe. Have you tried the resistance to it? The wiring I got is the same. John says. BCM, Joshua says BCM. I don't think we have to go to BCM now. We were thinking about it. Try 150 ohm. We did try 220 and this works. On a BA Falcon 55 ohm will read empty. Yes. On a BA reads that. Just like I said, it was out of limit. Yep, looks like that was the case.
Joshua says, I want you to connect the sender back on with the register wheel connected. We can do that. I want you to connect the sender back on with the sensor. All right, let's go do that. Connect the sender unit with the wires connected back up again. Let's do that anyway. All right, let's go back there. Okay. All right, so green goes to green. Let me just do that real quick. Green goes to green and black goes to, sorry, the yellow goes to yellow. Hang on, let me make a good connection here. All right, I've got everything hooked up the way it was before, and my fuel gauge is still showing 41%. Let's just give it some time to, do whatever it has to do. Okay, I'll just cycle the key on and off. I'm still reading half a tank, about half a tank, 41%. So even with everything connected, everything is working now. Okay, let me just quickly do one more thing like we did before. We directly shorted that wire together. Let's see what that gives us. Okay, I'm going to short them wires together. All right. Shorted the wire together coming out of the BCM. Nothing is changing on the fuel indicator control so far. Definitely got a good connection there because I can show you that's the open circuit, and the fuel indicator drops to 0.1% on the scan tool, you can see, right? And my fuel gauge on the dash is looking like it's below 0. Now let's connect that, bridge them together, sending earth into that signal wire. Let's wait for the scan tool to react. Maybe we set a fault code this time. We don't know. Let's just wait. It's not reacting. Make sure my connection is true here. Okay, here we go. Still nothing. Maybe we set a fault code by having an open circuit. Let me turn the key off and back on. Nothing is changing. Nothing is changing on the scan tool as well. All right, let me clear the fault code and let's see what happens here. Go to my trouble codes. Let me quickly scan everything again. Hang on, let me just come back. Pause that. Control unit. Let's go to IPC. Excuse me. Scan tool is taking its time for IPC communication. Let's erase that fault code. Let's see if the fault code comes back on for us again. Invalid data received from the control unit. Okay, let's go to the BCM and erase that fault code at the BCM as well. Trouble codes.
erase the fault code. And my fault code is still there. It does not like that shorting out. Okay, so let me go back and put my resistor again. Okay, as soon as I put my resistor, I can see everything is working. So it's not necessary to erase the fault code at all here. Okay, my live data is showing me fuel again. So it must be direct short's not going to work in this case. Okay, direct short is not going to work in this case. Okay, every day we learn something new here. Fuel level right there, I'll show you that. Graph that out, you can see 41. Now, before when we put earth into that signal wire with the test light, it wasn't working, right? So let's see if it works this time, right? Just I'm curious here. Where did we go wrong on our diagnosis? Shouldn't be this hard, but we obviously made it hard. Okay, I got the earth coming through my test light, right, with the jumper. I'm going to put that into my signal wire here. Obviously. Okay, and I am dropped to 1% on my gauge, right? So feeding earth via test light is not going to work here. So how about we get earth directly from the wire coming out of the computer? No, that's not going to work either. Okay, that's not going to work either. Now, what I like to really quickly check here is, how many voltages are coming out of that signal wire? Before we saw around 3 volts. Okay. Let me go to my voltage reading here, and I'm going to just check how much voltage is coming out of that wire. We're still sitting on the same voltage range here, 2.6, doing the exact same thing, right? Now let me put the resistor with everything hooked up. I'm still showing nothing on the fuel gauge. Okay, so we're going to put that there. I want to see a voltage reading right there. So we dropped to 0.1 volt on the meter, roughly 0. And it's dropping, right? So let me just change that register wheel, different range. I'm not being able to change much here. 0.3 volt, which is my 94% on the fuel gauge. 0.4 volt, 0.5 volt. So I could select any ohm here and I could make a change here. Okay, I'm going down now on the resistance. I'm at 82,000, 86,000. It's dropping to 0.2. But nothing is dropping for me on the fuel gauge. Oh, it's dropping now all of a sudden, everything. So we probably disturbed that signal. But I'm seeing 0.1 volt, 0.16 volt, but my indicator shows otherwise. Let's go back to 3 volt. Is that showing me anything? Nothing. Let's go back to 1 volt. Okay, I come up 94, 59, 57, 56% on the fuel gauge. I'm slowly just turning the register wheel. I went to 0.4 volt now. Let me see what it does. 0.4 volt. Still nothing changing. I heard a beep in the car and I think it locked the fault code, dropped to 1 volt. So it does not like 0.4 volt, 0.3 volt. Okay, so I'm around 1 volt, 0.1 volt range there. It's a very slow reaction time here. I'm at 2.5 volt. Still nothing. 0.2 volt, still nothing. Okay, here we go. I don't know. I think we just on a the resistance we measuring is we sending is out of whack here. That's what's happening. Prasanna says, leave the gauge at full, you never need to read. Okay, fair enough. Joshua said, never heard of them. Okay, cool. Cars are getting smart for its own good. This is the first time for me. Okay, there we go. Do you friend from Romano's Automotive? No, I don't know who Romano's Automotive is. All right, there we have it. It's getting late. I don't think anyone's watching, but I will continue a little bit more. I just want to know exactly what's happening here, because I can't be having this issue in the future. That's my whole point. So you guys can have a good night if you guys want to go to bed, but I'm going to continue a little bit longer here. I need to get to the bottom of it. But we know that the fuel sender unit is the problem. That's going to fix the car, so there's no question about it. But I just want to know the theory behind it, how it works and whatnot. Okay. Okay, no more comments coming through, so it looks like everyone's left me. That's no problem. All right, we're sitting at 10% again. So it's a very slow reaction time. You can't just put the register, you got to wait a while to, I don't know. So I'm reading 0.087. Like very, very small number here, guys. So what I want to do is I want to induce some voltage you know, so I can control how much voltage I'm sending out instead of using the resistor wheel. I want to do that. So, but before we do that, let's see if we need this earth to do its job connected, or we can do just using the body earth. Okay, let me just try. If you use the resistor, just using a body earth, can we make it, do we still need that earth coming from the BCM or not? I'm trying to figure out the design here. Okay, so I'm gonna feed earth into my resistor wheel. Okay, and I'm gonna send that resistance value via only using the body earth. Or do we need that green wire to in the picture to change the voltages here? Okay, so I'm not gonna connect to my green wire, nothing, open. We know there's an earth there. We have the signal wire, which is my yellow wire, so I'm gonna take that using the resistor wheel directly to body ground instead of using the green wire. And I'm seeing nothing on the multimeter. Maybe my multimeter is not connected. Let me see. Yep, let me just grab another earth here for the multimeter so I can read the voltage at the same time. Okay, so we're reading 0.01 volt and I'm reading 4% on the scan tool. Let me go back to that 220 ohm number we had where it was showing 50% fuel. Alright, it's not really showing me much right now. Let me increase that resistance. That reaction time on that scan tool is very, very slow, I believe. So I'm at 0.1 volt. .1 volt again, 0.08. Not much changes here for some reason. I'm still sitting at 6% fuel. Now it jumped up to 59. It's very slow, definitely very slow reaction on the time you put the resistance, and scan tool computer reaction time is very, very slow. But literally I'm seeing 0.01 volts in that wire right now, and it's showing me 59%. That's a very, very little voltage here. It is very strange. So we know that we do not need that green wire, that earth wire coming from the BCM. We do not need that. So that can be out of the picture. I'm seeing 0.05 volt. That's a very tiny voltage. And I'm seeing almost 3/4 tank, right? Ignition on, ignition off. Let me just see if that does anything. No, the scan tool just come down 0 and back up. So here we have it, guys. 59% fuel, almost 3/4 of the fuel, 3/4 half a tank of this fuel gauge is showing me 0.00 volt. That's strange. Very, very strange. That's tiny, tiny. Are you going to reverse engineer that? I'm still up. I'm not going to reverse engineer. I don't know what am I doing at the moment. I'm just trying to figure it out what's going on here. Don't burn the BCM. Nah, I'm not gonna burn it, I'm pretty sure. DJ, got to get my hands on one of those resistance wheel. I know that they discontinued it, but it's really useful tool. Yes, but today I don't know what's happening. It should be a very simple circuit, but nothing looking simple here so far. So let me go back to this wiring diagram again quickly. Fuel pump directly goes to the BCM, and it says the green wire is the pump ground, and my yellow wire is a pump sensor. That's it. But they don't show me anything inside the BCM, how it works, and that is fantastic sometimes. Our trade, right? All right, I am tired and I'm hungry. I know I'm complaining now, so I'm going to have a quick few minutes break. If you guys want to stay, you can stay. I'm going to continue to figure it out exactly what else can we do, just in case in the future I don't have to go through this drama again. But if you want to leave, that's understanding too. You should have this live video on the YouTube. You can watch it later. All right, I'm just going to go for a quick break. I'll just show you the wiring diagram. If you want to watch it, if you want to watch the gauge sitting at 59%, that's the wiring diagram. I'll let you quickly go through that. Okay, that's my wiring diagram. That's all I have, guys, here. That's all I actually have here. Okay, so that's my sender unit right here. Right, follow those two wires, goes to my BCM. That's it. That's all we got. Okay, so I'll just quickly draw that so you guys can understand what I'm looking at. So we're looking at this area right here, coming down, that area, up, this way, up. That's it. That's our wiring diagram, and that is my BCM right at the top, BCM. That's it. This is my BCM. This is my fuel sender. So we got yellow wire here and a green wire at the top. That's it. John says goodbye. Goodbye, John. Thanks for joining in tonight. Prasanna says it's programmed to change slowly. It will prevent fluctuation of the gauge. True, true. Very true. But it just sucks for us to diagnose it. You know what I'm saying? Because we want to see the change quickly, but obviously not. So I'm just going to quickly go have a drink and a break. I'll be back, guys. If you want to stay, good. If not, have a good night, everyone. Joshua.
I'm back. If anyone's watching, I don't expect anyone to be here at this late. If you're from overseas, maybe different story. Prasan says, thank you, brother. Thank you. I thought this is going to be a very quick video, but hey, hello, welcome to our trade. DJ says, I'm still here, bro. Question, are you doing this online testing weekly? Seeing that I am on the other side of the world, I would like to catch the training from the start. I do it like I did one yesterday, last night as well. So I do it whenever I have a car that needs diagnostic, electrical diagnosis. I don't really do mechanical stuff, but anytime I have an electrical diagnosis, I usually like to keep the car overnight so I can make videos. So, but yeah, once or twice, 3, 4 times, depending on the job, DJ. DJ also says, so I can set my alarm. I went to your page to see if there was a notification, but I saw the training and just logged on. If I know in advance, I can log on and share it with others to view also. Yeah, that would be great, DJ. Thank you, DJ. All right, let's go quickly through this. Let's try a few different ways of testing this. I just really want to know what's going on there. It's just not making sense to me. So simply put, all I was expecting here, honestly, is 5 volt on my signal wire and earth. That's all I was expecting, but we are seeing 3 volts here, and 3 volts was going from 2.5 up to 3.2, 3, 4 volt, and then coming down and up like that. So some kind of strategy that computer is you know, doing there. So we don't know. Like we said, we're not engineers. We just trying to fix a car, diagnose, and sometimes this is what we get. At this point, like I said, if we were a little bit patient before with the register wheel, we could have probably diagnosed this car way earlier, but now we got more opportunity to learn about this technology. Not only that, we already know, this video is very long, but we already know that this thing's going to need a sender unit. You know, we could have simply just done a open test, the resistance test, and we saw that was enough to call it a sender unit, but we still wanted to verify the wiring. There could be other problems as well. So that's where we're at. Let's just keep going here. So next step, what I want to do is I want to probably throw in a scope. I want to quickly see what I see on the scope. We're only using the multimeter tonight. Okay, so that's my wiring. Again, 2 wires, yellow and green. Green is earth, yellow is my signal. So let's throw that in there, and then I'm going to go and do some testing on the wirings. I'll just see if my camera can capture everything here. Probably I'll move. Now I'll keep that there. That should be enough to view everything. I'll move that camera up a little bit. Okay, let's go do some testing. DJ says voltage drop. I don't know what you're referring to there, DJ. We're gonna just get a scope reading now. Let's see what we got.
Okay. I'm just gonna use my tail to do my scoping here. I'm just not gonna pull my picoscope out. Let's go a split screen maybe, measurements. Let's go oscilloscope. Okay, let's measure check our scope first, make sure we're getting our true readings here. So I'm showing 12 volts, which is good. Okay. Right, I'm gonna go with the scope on my signal wire here. Alright, I'll go to my voltage setting. Let's go 20 volts maybe. Maybe not 20 volts, let's go 5 volts. Change my time scale a little bit here. Let's just go 1 second. We got some activities happening there. It's going from 0 to 2 volt. Cool. Alright, we got, let me increase that. Let me get that, hang on. Let me change that to 50 millisecond. We can see some duty cycle there, 0, 2 volt. It's going up and down 0, 2 volt. My meter is showing 0.017 volt, obviously. My multimeter is not as fast as my scope. Alright, that's what we are seeing here, guys. DJ has a meaning. DJ says, meaning if there's supposed to be a 5 volt and a ground, why are you getting approximately 3 volt? The float will have a resistance on it, but how come it dropped that low? There you go. That's why. That's what we're trying to find out. Is the 5 volt unplug the harness of the fuel gauge? Yeah, we cut the wire. We cut the wire completely. The fuel gauge is not, the fuel sender unit is not connected at all on that wiring. Both wires are disconnected at this stage. Alright, that's what we're seeing right there. DJ, if you can understand what I'm saying. See those wire we cut? Both the wire going towards the carpet is going to my fuel tank. We cut both the wire, the earth and the signal, both wire. So I'm doing the measurement on the wiring going into the BCM. That's where we at. Okay. Alright, that's what we're seeing, guys. 0.2 volt. Some kind of duty cycle looking pattern there with the 59% fuel gauge control, fuel gauge percentage. Okay, that's where we at. All right, DJ Prasanna says, share with LM Auto Repairs and Romano's Automotive to get more followers. I really don't know who they are. I'll look up, but I don't know if they're going to help me or not. I'll look up there, Prasanna. Thank you so much. All right, guys, what else do you guys want to see? So the BCM is controlling the fuel gauge. What do you mean, DJ? So like I showed you on the board earlier, I'll just go through again. I think you missed that earlier, right? So the sender level, sender unit goes to the BCM, those two wires, and then BCM then communicate that information to instrumental panel, IPS. And that's how you see on the gauge, on the dashboard. That's the layout here. Okay. Is PWM from the BCM? Wow. Yeah, the pulse width is coming from the BCM. Looks like it. Okay, so I'm gonna go do some changes there, and let's see what we can find, right? So currently on my multimeter, you can see I got 1.7 volt, right? But obviously it's not going to show us pulse width modulation duty cycle type signal. We got 0.2 on the scope. So I'm just going to quickly go and change the resistance, right? I'm just using the resistance wheel again. Let me drop it down. And on the scope, you can see 1.8 maybe. Drop it down to 56.01 volt. Signal, you can see the fuel gauge come up 94%. Okay. Now let's change with that resistance change, 33 ohm. My duty cycle is getting smaller and smaller. You can see it's almost like 0. Very, very little voltage duty cycle pulse width there. But my gauge is still showing 94. That's almost 0 on my scope. And we got a large jump here. I got over voltage. Very, very large voltage here. Let me just change that voltage scale to 20 volt. Let's see how many volt we're seeing. We're seeing about 6 or 7 volt. Hang on, let me see. About 5 volt there on my meter. Hopefully my meter is connected here. Let me just double check that. No, sorry, my meter is not connected. Let me connect my meter. Sorry, that's the earth. I'll connect my meter at the same time. So on the scan tool, we are on the scope, we can see 5 volt, roughly around 5 volt, right? My fuel gauge indicator is 1. I can hear the dashboard made a sound, a buzzing sound. So what that means is maybe we set a fault code now. That's not the voltage computer wants to see. So 0.5 volt we're hovering around, but on the scope we can see it's going up and down, doing exactly the same when we had the fault in the beginning of the video. So let me change that resistance value. So I'm at 5 million ohm at the moment. Let me go to 1 million ohm. My voltage level staying still same. Let me go back 4,000, 3,000, 1,000 ohms. I'm just looking at the scope, guys, as I'm turning the resistance wheel here. Nothing has changed on the scope so far. Let me keep going here. Nothing has changed. There you go. As soon as I hit, hang on. it's working now, but we're still seeing 5 volt pulse width on the scope though. Let me keep going here. We're showing 84%. Maybe the computer is taking its time to obviously measure that percentage maybe, but scope hasn't changed much here. Alright, I heard a beep again. We've locked the fault code and the scan tool dropped. Let me go back again. Alright, there you go, come up right there at 2.2 kilo ohm. It come up. My voltage level hasn't changed much though on the scope, has it? Let me go back one step. Let me just bring that cursor down a bit. Where's my cursors? Alright, that's where we're at, 4.68 volt. Let me go back this way a bit. It did not like that voltage reading right there, which was over 5 volt, just over 5 volt. Sorry, my connection come off here. Just over 5 volt, the computer did not like that reading. It doesn't react till I go a very long way here. I keep scrolling through the register. Looks like my voltage is slowly coming down as I'm turning that wheel. 4.97. There you go, that's where you found it, 1.5 kilo ohm, and my voltage dropped to about 4.4 volt duty cycle. That's when it started reacting. All right, let me see if I can keep dropping that voltage. You can see my voltage level is drastically dropping as I'm dropping the resistance. 27. Still reading 27, but my voltage level has now, as soon as I get there, the voltage level rose a very high level. Let me measure that. So I got about 1 volt, 900 millivolt on 1 volt, and went up 94% fuel. Let me go back the other way. It doesn't react very quickly though. Yeah, there you go, 73 as voltage is rising. So we at 2 volt now. Voltage is going up and my fuel percentage is coming down. We are at around 4 volts now. There's no change after that. 60% stuck. My voltage dropped, everything went up. So let's see what we're doing here. I have to do it very slow, I think, here. At certain resistance, it doesn't make any changes on the fuel level. As soon as you find that sweet resistance it wants to see, and then start reacting right there. It went from 82 to 81 very quickly to 94. Yeah, I'm trying to give you the range which resistance level is good for this test, but I can't really find that sweet spot. Very, very slow reaction. So anyway, so we got a duty cycle kind of signal happening here between almost no voltage, 0 volt, to a 5 volt pulse width modulation here, right? Okay, that's where we got. All right, we got some comment, guys. Rob from Tata, he is referring to. Rob from Tata. Rob from Tata. I don't know what that means. You mean Tata? Is a company, Indian car company, Tata, right? Yeah, are you talking about that? Rob, I don't know. Solid dude. Really, I can't give you a solid answer tonight. It's not making sense. I have never seen a pulse width modulation like that on a fuel gauge circuit. This is the first time. If it is a pulse width modulation, Prasanna Shan, if it's pulse width modulation, I don't see pulse width changing. Am I wrong? I don't see the width changing, but it's got that pulse width type signal. Obviously the percentage of the pulse width is not changing, but the height of the voltage is changing, however. Is it still safe to say it's a pulse width modulation signal, or is there a different name for this type of signal? I don't know. If you guys know, just throw a comment there for me. Well, it's still a pulse width modulation. Just because it doesn't change doesn't mean it's not a pulse PWM signal, right? Okay, what's next? All right, next thing I want to do is I want to quickly induce some voltage down that wire, and let's see if you can make that changes or not. Excuse me. All right, I'm going to use my scan tool function, the multimeter, or voltage active voltage generator, and then I'm going to induce some voltage there. Let's see what we can find. Okay, let's go battery let's go positive and negative on my scope. Let's put the leads. I don't think we need the negative, but let's just put it on anyway. All right, I'm just going to use the voltage generator here. Let's go. Let's go back here to my measurement, and we go the waveform generator. Okay, do it again. Waveform generator. Let's get rid of that. All right, I'm gonna select DC voltage. I'm gonna put DC voltage direct down there. Let's see what happens. Voltage level. Is that not right? Is that not right? Is this not showing up? Why is showing frequency? Am I on the wrong page here? Let me try again. Multimeter function, is that where I'm gonna find that? No, don't think so. No, that's just that's just the multimeter function. Where is my voltage supply here? It's got to be in that, isn't it? Yeah, it's got to be on the waveform generator. Alright, I'm going to put my positive lead for the waveform generator into that signal wire. And play that. Oh, you got to hit the play before this voltage settings come up. Okay, there you go. All right, so I'm sending 5 volts now, and I'm seeing 36% on the on the scope there. Okay. Now let's increase that voltage level. I'm at 5.9 volt. I'm sending. Nothing has changed on the scope. I'm sending 7 volt, and the fault code logged. You can see the fuel gauge indicator dropped to 1. Let me drop it back to 5.9. Let's just wait. Let's see if that gauge start working again. Excuse me. Nothing has changed. Let me drop that voltage to 4.9. Nothing's happening. That's 4 volt. As soon as I drop it to 4 volt, 3.9, like in the corner you can see, I'm getting 34% fuel. Let's go back down. 2.9 volt. 3.9 volts, 31%. Hang on. Try again. 3.9 volt is 30%, 29. 2.9 volts is 28%. 1.9, so it's still at 2 volt. Let me just go down a 0.1 volt at a time, okay? Okay, so we got 2 volt. Let's come down, 1 volt. Hang on. 1 volt. 1.1 is 92.89. 1.2 is 85. 1.3 is 84. 1.4 is 82. 1.5 volts, 78. 1.6 volt, still dropping slowly. It's obviously taking its time. 71. 1.7 volt is 71. 1.8 volt. Nothing's changing. 1.9 volts, nothing's changing. Nothing is changing still. Nothing changing. Oh, it changed to 69 when it went to 2 point something volt. Let's keep going up. Let's go to about 5 volt to the extreme. 4.6, 4.9, 5 volt. Let's see what happens at 5 volt. So I'm seeing 5 volt on the meter as well. I'm sending 5 volt down there, that wire, and I am seeing 64%. So let's go down all the way to, let's drop it down rapidly here. Let's see how much changes we get. It's not really dropping. All right, it's almost 0 volt. 0.1 volt. It goes to 94% at 0.1 volt. Okay, let's go up. 0.2 volts, 0.3 volt, 0.4 volt. You can also see how much voltage I'm inducing on that multimeter as well. Nothing changing. 5 volt, nothing changing. 0.7, nothing changing. 8, 9, 1 volt. 1.3 volts started doing making some changes. Let's go back to 1 again. Goes up to 92. Below 1, it changes a little bit. Yeah, not much though. This changes a little bit between that 0 to 1 volt range. Let's go to 1 volt. So 1 volt means about 92. Let's go increase 1.1. It's dropping slowly. 1.2 dropping slowly. 1.3 volts dropping. 1.5 volts dropping. 1.6 volt dropping. Keep dropping. 1.9 volt. It's at 70%. Let's go. Let's see, no changes at 2 volt. Let's go 2.1 volt, nothing changing. 2.2 volt, it dropped a bit again. 2.3, not much change. 2.4, not much change. 2.5, not much change. 2.6, dropped 1% there. 2.6 volt. 2.7 volt, excuse me. And dropped one more. 2.8 dropped. Didn't drop that. 2.9, 67. 2.3 volts, 67. Okay. 65, 3.3, 64. We keep going. At 4 volt, we got 54 volts. We got 56, 55, 54. It's dropping. 53, 52. Obviously, the reaction time is really, really slow here. 53, 50, 48, 46, 45, 44. So looks like the higher the number, voltage, the higher the voltage, lower the fuel level. So lower the voltage. Let's say around 1 volt we saw 90 something percent. At 4 volt we're seeing about, it's still dropping, seeing about 30, 31%. So I think this is a better way to test this type of fuel sending circuit. I can make a lot of changes here, and I can see exactly what's the voltage level. Resistor can still do it, but sometimes, you know, like we did tonight, you can, you know, it can throw you off, you know. So I'm at 4 volt and it's still dropping. It continues to drop. 18%, 17%. It's continuing to drop. That's see where it ends. Okay, 14, still dropping, still dropping. 13. 12. So I just heard a beep. I think we set a fault code right now at 4 volt. But we are still seeing 9%, so it stayed at 9%, okay? Now it's still dropping 8. At least we can see something, and also on the gauge I can see the needle is above the red mark, above 0 mark, okay? It's still dropping at 4 volt. Looks like it's staying at 7 now. Okay, it's not okay, it's still going. It's taking its time, but it's still dropping. I think the beep, the buzzer we heard before was, I think the fuel was on reserve. The low fuel light came on. I think that's what the noise we were hearing, the beep. All right, it stayed at 6 volt now. Still dropping, still dropping. My voltage level hasn't changed. I'm continue to giving it 4 volt. Okay. Prasanna said, if it is a pulse width modulation, I don't see pulse width changing. Am I wrong? No, you're not wrong. Pulse width, the width hasn't changed, but the amplitude is changing. So it's called AM. There you go, AM, amplitude modulation. There you go, amplitude modulation. Thanks for that, Prasanna. I don't have a big vocabulary of you know, all the words, so even if I know what it is, sometimes I don't know the word or the exact you know, name for it. So thank you for letting us know. Amplitude modulation. I really don't think anyone's watching at this stage, to be honest. But anyway, I'm still watching that voltage is come down to 3 volt now. But at least we know 4 volt can energize that circuit, and staying at 3. And it's staying at 3, okay? Let me see if I can change that voltage. So let me go up to 5 volt this time. Let's add another voltage there. I'm at 5 volt, 4.98 it's showing me on the scope there, but I'm inducing 5 volt there, and nothing is changing on the indicator. Let's go more than 5 volt. Let's go 5.5 volt, 6 volt, still nothing's changing. Let's go 6 volts. Drop to 1. Let's go a little bit more than 6 volt. All right, still nothing. 7 volt. Still nothing. So my percentage, however, has dropped. At 7 volt, it's 1%. Nothing is changing here. I don't want to give too much voltage here. Let me go down. We don't want to take a risk here. I don't know how much voltage is safe for this. So let me go down to 3 volts again. So let's go 3 volts. It went up a little bit. It's climbing up now on 3 volts. So looks like 4 volts gonna give you the lowest number, 1% fuel, and the highest, sorry, the 4 volt, yeah, and if we go down to about 0.1 volt, is gonna give you that full maximum percentage of fuel level. Okay, that's where we're at. Okay. So simply put, in this type of design, I'll just cancel that real quick. Stop the power feed. I'm just going to put direct earth one more time here. All right, I'm going to give direct earth in that on that wire one more time. So let me go back to scope real quick here. Oscilloscope. So right now we have some kind of pulse width signal, 0 to up to about 5 volts when it's open circuit, right? So I hope I'm not giving anything here. No, I'm not giving any resistance. It's open circuit. Yeah, my scope and my multimeter, my scope is connected. That's it. So it's just good. Let me get rid of that resistance wheel as well. So I'm open circuit at the moment, right? On the scope you can see about 0.5 volts pulse width according to Prasanna amplitude modulation. I want to put direct earth here, so I'm connected to earth directly on this jumper wire, right? So I'm going to put that earth directly there, and let's see what happens. So I'm dropping all the voltage on the scope to ground, and on the fuel gauge indicator I'm seeing 1%. I was hoping I would probably see a fault here, but it's not. It's sitting at 1. So let me go and quickly see if there's a fault code for this. We do have a fault code, but let me just erase that fault real quick. Let's see if it comes back on when we ground that circuit. So the fault hasn't returned, at least on my IPC instrumental cluster. Let me see if the BCM has that fault code stored or not. And let's clear that fault code as well when we ground this circuit. Erase that fault. Alright, so that did not clear the fault code. So definitely we're setting a fault code when we ground that signal wire. There we have it. So it will work between, I think it's 1 to, so let me go back to IPC again. Intermittent cluster, let me just see that live data again. For the fuel gauge indicator, okay. So it's at 1%, that is a fault, okay. So let me get that bridge, and we're seeing that pulse looking signal again. I'm sure still fault. Okay, now let me go to my voltage. Let me induce some voltage here. So let's get rid of that. Let me go back to inducing the voltage again. Let me induce some voltage right there. All right. So right now I'm giving 0.1 of a volt here. Okay, let's add that voltage up. Yes, so it went up to 94%. So as soon as I give 0.1 of a volt, it goes up to 94%, but it does not like ground. So if I put ground here, it does not like ground. Okay, if you guys are following me here. So let me try that again. If I put ground here, that drops completely. So it does not like ground, but it likes 0.1 volt. All I'm giving is 0.1 volt, and it goes up to 94%. Let's add that. The higher the voltage, the lower the fuel level. So anywhere from 0.1 to 5 volt is pretty safe here. Looking at the thing here, that's what it looks like. Okay, definitely we can do that. Now let me just get rid of that, and let me find my, I can't do that on the scope. I wanted to bring the scope and the wave generator at the same time, but I don't think I can do that. That's fine. So anyway, there we have it, guys. There we have it. That's how it's gonna work, this one. Okay, I stopped giving voltage, and it I'm still at 0.6 volt. Let's stop giving voltage. I'm dropped to 0 volt. This would be absolutely no voltage, but I'm still seeing 0.6 volt. How come? Maybe I haven't shut this down properly. Okay, let me go to scope. That should shut my other. Now it's showing me 0.6 volt. I think that's the voltage coming from the. It's coming down rapidly. That could be some kind of, voltage coming from the BCM anyway, because I'm not giving any voltage at this stage. All right, there you go. And as soon as I put some voltage down that as soon as I put some resistance there, it's tend to work. Okay, I'm gonna just try to put some resistor, being a register being a sender unit here again. I'm going to introduce that again, back on that. So as soon as I put some resistor there, the duty cycle, the shape of it changes. See how it's got that curvy looking, waveform at the bottom? As soon as I put some resistor, it changes. There you go, to square wave looking pattern. So that must be a fault code. And that is everything working. Okay, there we go. However, my percentage hasn't dropped, even if it's an open circuit here on the fuel. Just disconnect everything here. So I got both the wire exposed. My fuel gauge control hasn't changed for some reason. Now it's a open circuit. Nothing is connected. On the dash, my gauge, okay, there you go. It took its time, then it's dropped. Okay. All right, there we have it, guys. Go and make sense out of this, but at least we know next time we got a Ford Focus, we can't just simply check it the traditional way we used to check it, right? What do we have here? Prasanna has a question. Prasanna says, what was that site that gives free wiring diagram again? No problem, I'll put that up on the screen for you. So this is the website right here. So I'll just close that off. So basically you're going to have to go to this website, cardiag.com. That's where you have to go, right? There you go, cardiag.com. And you can select any brand here, anything you like. So let's go Holden. Let's go, I don't know, Holden, Great Wall. I don't know what you guys use over, what type of cars you see over there, where are you from. Let's go Honda CR-V X, and you can find all the, Hondas, whatever they have in, wiring diagram uploaded there. Let's try a different one. Let's try Chevrolet. I got Chevrolet, I don't know, let's go Cruze, Chevrolet Cruze, and you got 2016 Cruze here, wiring diagram, 13, workshop manual 2010, Cruze body repair, that must be for the body shop, painting body shop, right? So this is the website, guys, cardiag.com, okay. Now we have another comment from DJ. When a vehicle is giving me trouble like this, I just walk away and try it next day. Yeah, I know. I would probably do the same, but I wanted to get this through because I didn't want to set up the equipment for live recording tomorrow again. So probably we'll do some other cars tomorrow. So yeah, DJ, thank you for that comment. Well, that's pretty much it. If anyone's still watching, let me know what else you want me to do, but I think that's pretty much everything here. We covered basically everything. Before you go, I can quickly show you where that BCM is. It's under the dash, behind the glove box. Okay, behind the glove box. It's just a part of the fuse box. Looks like it is a fuse box. Anyone looking for that? And there is no fuel access door on this vehicle, right? There's no fuel access door for this vehicle under the seat. So you're going to have to pull the fuel tank out, which is going to be pain for me because the tank is full, like completely full on this one. So that is going to be a fun job. Any last comment, thoughts, concern, anything? Anyone wants to know anything more here, guys? I'm still here. And by the way, this is a torch. It's called a neck torch. So you just put it there and just shine the light as you're working. You can twist it around. It's a flexible handle there. Not handle, flexible, whatever you want to call it, band, right? You can just select up and down. Pretty cool stuff, this one. Neck light, it's called. Okay, Prasanna says thank you. It's been a long night, but I hope everyone can get something out of this video. DJ, if you're still on the chat, any last thought, concern, anything like that? Like, seriously guys, if you guys can share these videos and whatnot, I'll really appreciate it. Make sure you like that thumbs up, button. Like my videos, so YouTube can sort of recognize what I'm doing, and other people can reach to my videos. Definitely thank you guys for staying with me. So let's quickly, for other viewers, just to wrap it up, I'll just quickly explain to you on the board here what's happening. Right, so everyone can understand if they want a quick information. Okay, let's do this last bit and then we can wrap up the video. All right, so this still applies. So basically we got a COM line here, so CAN bus system, some kind of bus line, right? BCM to IPC, that's how it's going to get the information to the instrumental cluster. From the sender unit, we saw two thin wires going into the BCM, right? So one has earth, let's say this is our earth wire, permanent earth, nothing changes there. And then we have a signal wire here. On the signal wire, what we saw was some kinds of amplitude modulation, as what Prasanna says. I don't know, is that the right word for that characteristic, but amplitude modulation, modulation we got, right? So basically the width doesn't change, but the amplitude, the height of the voltage is changing. So what we saw was, basically 0 line here. Let's go up to about 5 volt here. So what we saw was, we saw a pattern like that. Keep repeating pattern like that when it's at open circuit. Okay, this is open circuit. And then when we induce voltage, or when you induce resistor, being a sender unit, this pattern changed. This pattern changed into something else. It changed into a pattern like a square wave. Okay, so 0 volt again and 5 volt, let's say. So it went from kind of depending on the fuel level, it went from, depending on the fuel level or the register's value, it went kind of like a square wave. You know, there was no change on the pulse width, yeah, time-wise, but there was change on the modulation as the voltage or level, fuel level changes. It changed the height of it, but the width didn't change. Okay, something like that we saw, right? So that was the pattern we saw, and we tried to induce the voltage with using our voltage generator, and we could safely put anywhere from 0 volt, sorry, not 0 volt, anywhere from 0.1 volt up towards let's say 4.9 volt, and you could change that signal using those voltage ranges. We didn't have to send a pulse width modulated or the amplitude modulated type signal. We could just simply send straight voltage 0.1 to 4.9. As soon as you see 0, that's a fault. As soon as you see 0 or earth, that was a fault. But anywhere between that voltage and that voltage range, it was going up and down, no problem. So when we were at, as we saw, when we were at around, this is a round figure because it was very slow response on the fuel gauge system, right? Even if you induce voltage, it takes its time to change that level, percentage level of the fuel. So we saw about 0.1, around that figure, we were seeing around maximum, let's say, fuel level, okay, which was about 94%, I think we saw, and around 4 volt, we were seeing minimum fuel level, which was around, let's say 1 or 2%, something like that, okay? That's what we saw today. All right. Prasanna says, you deserve more followers, man. I wish, but that's fine. It will slowly get there, I guess. People are too busy watching TikTok videos these days. They don't want to learn, man. I've had people, like, seriously, at my work, right? I had people where I worked in the past, or people working with me. I want to teach them, but they don't want to learn. Even if you show them, okay, hey, come spend half an hour with me, I'll show you exactly, like, you know, you'll learn so much in half an hour. They don't want to learn. And yeah, this is the technician we have in the field. They just refuse to learn. I don't know why. This is a case study, right? Well, it is, I guess. I'm just doing my job. Many need to join with you. Appreciate your work. I appreciate watching it, Prasan. Where are you from anyway, Prasan? Prasan, where are you from? If you're still in the chat, it's okay if you're not, that's fine. I'll just have a bit of an interaction with whoever left on the chat. before I shut it down, if you guys want. Prasann, you can comment on the other YouTube channels which I said before to get more followers for your channel. So just go and comment my channel details on their videos. Is that what you're saying, Prasann? I don't know if I want to do that, but yeah, that's a good idea, I guess. Where are you from, Prasann? Which country you're from? Do you live in Australia or do you live overseas? I was in UK, yes, now in Sri Lanka. Oh, Jesus, Sri Lanka, brother, how's everything going there? The news is not showing very good. News is not telling us a good story there, brother. Are you safe? Everything good? Anyway, guys, Prasann, stay safe, man. Thanks for joining, everyone. I will probably see you tomorrow. I do have one other car I need to diagnose. I think it's got a misfire. Customer says, I think some other mechanics told them it's got a head gasket issue. I did start at the car this afternoon. It sounded like just a ignition misfire maybe, or could be a fuel misfire. Didn't sound like a compression issue to me, but we can probably do something like that if you got time tomorrow, if you guys want to join in. Other than that, have a good night, guys. Hope you guys enjoy that, and I'll see you next time.